Today's lesson is on page 9 and is going to cover compound probability. So the definition of compound event is the combination of two or more events. So they will be asking you to find the probability of something and using the word either or the word and. So the first type we have is or events, and as I go over this, if you need to pause after I'm done talking about everything to make sure you have it written down, then please make sure you do that. So the first type that we have in our or events only, so just a couple things to know about them. Our or events are also known as the unions, and so we use this U symbol to represent them, and you'll see that throughout the formulas. And we also associate addition when it comes to or events. So the first type we have is mutually exclusive events. Those are events with no common outcome. Our formula for that is the probability of event A union B. So again, that's your symbol for or. So if you see that symbol, you need to think or. And then, so it's the probability of A or B. Well, that's going to be equal to the probability of A plus the probability of B. And that, an example of that is like being a freshman or being a sophomore. They have no overlap with each other, and you see that keyword of or there. Overlapping events are events having a common outcome. The formula for that, probability of A or B, that's that union symbol. This time we're going to take the probability of A, add it to the probability of B, but we must subtract the probability of A and B. So that symbol in there, looks like this. And that is just your overlap. So we must subtract the overlap. So one that is in both categories. And so if we're looking at an example, that's like being in art or being a girl. And your keyword of or is in there. And you could be in art class and also be a girl. So we'd have to subtract out the things that we counted twice, essentially. All right, our second type is our and events. Our and events are going to be our intersections, which we'll use that upside down in to symbolize. And whenever we see an and, we're going to also want to think multiplying. Okay? So events that do not affect each other are independent events. The probability of A and B, that's your symbol, will be equal to the probability of A times the probability of B. So when we see that symbol, we want to think multiply, which is why we're multiplying A and B together. This is like flipping a coin and, there's your keyword, rolling a dice. So if you think about it, flipping a coin has no effect on your what you get when you roll a dice. Dependent events are events that do affect each other. That's going to be the probability of A and B. So there's your symbol again. We are going to take the probability of A times the probability of B given A. So knowing that A already happened, what does that affect? And this is like drawing two cards, but drawing two cards without replacements. So essentially what this means is you've altered the sample space. So say you drew a card and you didn't put it back in the back. So now we're down a card. Or you drew a marble and you didn't put it back in the back. So your sample space will be affected. So let's just look at a couple examples. You need to make sure you know decks of playing cards. So if you want to pull up a picture, that way you can see them and you can figure out the different things that you have. So you randomly choose a card from the standard deck of 52 playing cards. Find the probability you choose a queen or an ace. Well, or means to add, so just keep that in mind. It's also your union symbol. So I'm finding the probability of a queen or an ace. That has no effect. Having a queen has no effect on having an ace. So these are going to be mutually exclusive events, and it's or. So that's just going to be the probability of a queen, or means to add, the probability of an ace. Well, out of my 52 cards, I have 4 that are a queen. And out of my 52 cards, I have 4 that are an ace. So that's going to equal 8 over 52, which makes sure that we are simple. And that will get me to 2 over 13. So the probability of getting 4 eighths. All right, let's look at number 3 down here. Find the probability that you choose a card at random. Actually, how about you guys pause and do number 4? All right, now looking at problem 3. Find the probability that you choose a card with an even number or a heart. So again, or means add, or means union. So I want the probability of an even or a heart. Well, if I look at my deck of cards, even numbers, I have the 2s, the 4s, the 6s, the 8s, and the 10s. Jack, Queen, King, I'm not going to be able to associate those with evens. So I have 4 2s, 4 4s, 4 6s, and 4 8s, and 4 10s. So 4 times 5, I have 20 total evens. Out of my 52 cards. I'm adding that to my probability of hearts. Well, in my hearts, that's a suit. So in my hearts, I have 13 whole hearts. So out of my 52 total cards. Now here's the problem. There is overlap here. And my overlap, what they all share, is going to be the 2 of hearts, because that's even and hearts. So I counted that twice. The 4 of hearts, the 6 of hearts, the 8 of hearts, and the 10 of hearts. So I have to subtract out my overlap, which is the 5 cards that I counted in both the evens and both the hearts. So when I subtract those out, I'm going to get 28 over 52. Always make sure you reduce. So I have 7 out of 13. Okay, you guys go ahead and pause the video and try number 2 on your own. I'll put this up here. And you'll also be asked to enter number 4 again, because I didn't have this up here that time around. All right, let's look at number 5. A coin is tossed, and a 6-sided die is rolled. Well, I see the word and is my intersection, and it also means to multiply. So I want the probability of a 6. Oh, shit. Okay. I want the probability that I have a coin showing heads and the die showing a 5. Those have no effect on each other. So the probability I flip and get a head, so that's 1 out of the 2 sides of the coin. Probability I get a 5 is 1 out of the 6 sides of the die. These are multiplying, so 1 12. Go ahead and pause the video and try number 6 on your own. Okay, let's look at number 7. An aquarium contains 6 male goldfish and 4 female goldfish. So I have a total of 10 goldfish. You randomly choose one fish from the tank without replacement. Then you select another fish from the tank. What is the probability that both fish are male? So, probability I get a male fish. And another male fish. Well, the probability I get a male fish to start is 6 out of the 10 I have in my tank. But here's the problem. I hypothetically pull a male fish and I don't put it back into that tank. Well, now my tank is down to 9 fish, and only 5 of them are male. And I'm multiplying. So this bottom number is going to change anytime that you aren't replacing something back in. The top number may change, it may not change. It depends on if you're drawing the same thing back to back or something different. So when I do that, I am going to get 30 over 90. Always reduce to 1/3 chance. Alright, on these ones, we are just trying to figure out if it's independent or dependent. If it's independent, then my probabilities will be equal when I multiply them. If not, then they're not going to be equal. So if I do this, this means multiply probability of A and B. So if I take my probability of B, 0.5, and times it by 0.7, do I get 0.35? When I do that, yes, I do get 0.35 equals 0.35. So this is an independent event because when I multiply my two probabilities together separately, I get what it is, my total. When I look at the other one, if I multiply probability of A times probability of B, do I get the probability of both of them together? I would get 0.6 equals 0.5. Is that true? No. So this is not independent. Okay, let's look at a table. Sometimes your data will be presented to you in a table, and we can just find things from that slide. So the table below shows the results of a survey of 11th grade and 12th grade students at Brookdale High School. Students were asked if they had a job last summer. We first want to figure out the totals for all of these. So my totals here, I have 40 students in 11th grade. I add 22. I have 40 students in 12th grade. I have 30 and 10. So I have 80 total students in the survey at 40 and 40. And then I have 48 total kids that have a job. I have 18 and 30. And I have 32 total kids that have no job. I have 42 and 10. And again, if I do 48, 32, I get that 80. So 80 total people were given this survey. In number 10, we want the probability of J and T. Well, J stands for job. So I want the probability they had a job. And they are a 12th grader, because T stands for 12th grade. Well, what's the probability of both of those things happening at the same time? I see an overlap right here at 30. So it's 30 out of how many total people did I give my survey to? 8. So it is 3 out of 8. Okay. All right, here we have probability of not a job or a union. Or a 12th grader. So on this one, probability of not a job. So these are separate. We're not going to be just looking for an intersection. And means intersection, which is where I look for just where they overlap. Or does not. So I'm going to look at my not a jobs. That's 32 out of the 80 total people in my survey. Or means to add. I'm going to look at my 12th graders. That is 40 out of my 80 total people in the survey. But if you notice, what did I look at twice? I looked at these 10 students twice. My 10 that are 12th graders and have no job. So remember, if there's overlap, we must subtract it out. That gives us a total of 62 out of 80. Always reduce, so 31 over 40. Okay, let's look at our last one. All right, on the last one, probability of no job or an 11th grader. So we're still adding. So probability of no job, that's not going to change from before. Before that was 32 out of 80. And if I go find that in my table, my probability of no job is 32 out of the 80 total that I gave this survey. 11th graders, that is a total of 40 people out of the 80 that we gave our survey to. Now again, check and see, we have some overlap happening here. We have 22 that we counted twice. So that 22 has to be taken out at least once because we counted it in both of our probabilities. So I would take out the overlap, and I would have 50 out of 80, always reduce, so 5 out of 80. All right, go ahead and pause the video and try number 13 on your own. There are no symbols in this, there are just the keywords. If it's and, look for the intersection between those two categories. If it is or, figure out the total in each category and make sure you look for the overlap and subtract it out. Please enter your answers and puzzle and answer.